Hello everybody, we are on our second lesson in our solutions unit. Yesterday we had some introductory background information, and today we are going to answer this question. How can we determine which compounds are soluble in water? So our focus is on aqueous solutions, and that means the solvent is water. So it is May 8th, and we will begin this lesson with a definition of solubility. Solubility is the amount of solute able to dissolve in a given amount of solvent. There are a number of factors impacting solubility. Yesterday we talked about the like dissolves like rule. So the nature of the substances that are being mixed together determines whether they will be soluble or not. Another factor that impacts solubility is temperature. So by far, the majority of substances will increase their solubility as temperature increases. There are exceptions though, and that is gases. If you think about that, gases, as shown in this particle diagram here, have high kinetic energy. They're literally bouncing off the walls. If I increase the temperature of a gas, I'm going to increase that average kinetic energy, and these are just not going to want to dissolve into another substance because of that. The third factor impacting solubility is pressure. As we increase the pressure of a system, gases will become more soluble, but solids and liquids remain unaffected. And again, we look at these particle diagrams here. If you recall, solids and liquids are considered condensed states of matter. You can't push these particles closer together, and therefore it's not going to make them more soluble under higher pressure conditions. But if we have a high pressure condition here for a gas, we are pushing the particles closer together, and that will allow that gas to become dissolved in a substance more readily. The next thing I'm excited to announce is that we are going to look at a new table in our reference tables. That is table F. So please, would you take out table F? This is going to allow us to predict the solubility of solutes in water. Okay, I've also taken out my periodic table because this is useful to look at as we read table F. So table F has the solubility guidelines for aqueous solutions. This table can be a little tricky to read, so I hope that this lesson will be very helpful for you. The first column, these are ions. They all have charges to them. Ions that form soluble compounds. They will dissolve in water, but there are some exceptions. Well, actually, there are no exceptions in these cases, but there are exceptions here. So halides like chlorine, bromine, and iodine are soluble in water except when combined with silver, lead, or mercury. Sulfates are soluble in water except when combined with silver, calcium, strontium, barium, or lead. Let's look over here now. Ions that form insoluble compounds. So the word insoluble means unable to dissolve in water. And there's a little asterisk. These compounds have very low solubility in water. So under unusual circumstances, these could be forcibly soluble in water, but under normal conditions, they are insoluble. But we have quite a few exceptions. So like carbonates, if I see a carbonate group, I'm going to say, hey, this is insoluble except if they're combined with group 1 ions or ammonium. So this is why I like to have the periodic table out. Here's our group 1 ions. So compounds that have carbonate associated with it are insoluble except if it's lithium carbonate, sodium carbonate, potassium carbonate, and so forth. All right, so we have some examples here that we will assess. Which of these compounds will readily dissolve in water? So readily dissolve meaning in normal conditions, you'll be able to put these substances into a beaker of water, mix it up, and it's going to dissolve, forming a homogeneous solution. Okay, so sodium chloride. Well, guess what? We did this example yesterday. I think we all know that salt is soluble in water, but let's use table F to make sure of that. Well, sodium, it's a group 1 ion, listed right here. Group 1 ions are soluble in water with no exception. Done. This is soluble. Silver chloride. Well, what I do when I'm looking at this chart, I look for both parts. I look for the silver and I look for the chlorine. And I'm going down here along the way. Whoa, we've got halides, halogens, halides. Chlorine is soluble in water except when combined with silver, lead, or mercury. Guess what? This is insoluble. Okay, we next have magnesium chloride. I'm looking down through here. We know it's a chloride, a halide. Halides are soluble except with silver, lead, and mercury. Guess what? This is, you're right, soluble. How about barium carbonate? And just noting where barium is, it's a group 2 element. There we go. There's our carbonate. Carbonates are insoluble in water except with group 1 ions or ammonia. Well, barium is a group 2 ion. So this is insoluble. Okay, what about manganese 2 sulfide? Here's manganese. It's got a charge of +2. Sulfide -2. Manganese 2 sulfide. I don't see any reference to manganese, but whoa, there's a sulfide. Sulfides are insoluble except in combination with group 1 or ammonia. That doesn't apply here. This is insoluble. Our 6th example, lithium sulfide. Sulfides are insoluble except if it's a group 1 ion or ammonium. Here's lithium, it's a group 1 ion. This is soluble. Let's look at precipitation reactions. So now we're going to have a full chemical reaction presented here, and we're going to assess this chemical reaction using our table F to determine if a precipitate forms. A precipitate is when you mix 2 liquid substances and a solid forms. It's a solid precipitate that forms, and we call them precipitation reactions. Our first example is sodium carbonate reacts with copper 2 sulfate to yield sodium sulfate and copper 2 carbonate. You'll notice in fine print here, I've got AQ. These are aqueous solutions. When I mix these two liquids together, these are the products formed. Let's assess if one of them is a precipitate. Sodium, group 1 ions are all soluble with no exceptions. And look, there's no, oh wait, there's sulfates too, by the way. Sulfates are soluble with exceptions of calcium, strontium, barium, lead, and silver. So guess what? This is a soluble substance. And I'm going to put an AQ here. Let's look at that copper 2 carbonate. As I scan through the table, here is our carbonate. Carbonates are insoluble with the exceptions of group 1 elements and ammonium. That doesn't apply here. This is insoluble, and because it's insoluble, it equals a precipitate, or PPT, which is a solid. So I could put a little S there too. So this is an example of a precipitation reaction because a precipitate comes out of solution. And what this would look like is you'd literally see like a cloudiness and a solid formation here. By the way, I hope you're recognizing what kind of chemical reaction this is from a former unit. You notice that sodium switches its partner. Sodium goes with sulfate, copper with carbonate. I hope you're recognizing that this is a double displacement reaction. Let's look at a few more examples. These two soluble liquids interact to form iron 2 carbonate. Here's our carbonate, it's insoluble. There's the exceptions. Well, guess what? This is insoluble because it's not one of the exceptions. So this is going to be a solid. It's going to be a precipitate. Well, what about this? Sodium sulfate. Sulfates are soluble. Sodium is not an exception. So this is soluble. Notice this is also a double displacement reaction. We have our third example for today. We've got lead nitrate, actually lead 2 nitrate, and potassium iodide, aqueous. We know that these are soluble. They interact in this double displacement reaction, and we get lead 2 iodide. Let's see if we can, oh, here's the halides, iodide. These are soluble except when combined with silver, lead, or mercury. This is insoluble. It is a solid precipitate. What about potassium nitrate? Group 1 potassium. They're soluble, no exceptions, and they even have nitrates are soluble, no exceptions. Also, please note, I've got my coefficients here to balance this equation. You know what? There's no coefficients up here, but it is balanced if you do your inventory. That will conclude today's lesson on Table F and the solubility guidelines. Have a wonderful day. Bye.